So in this video we are going to learn the chapter 8 motion of class 9th. Okay, so it is a very interesting topic. Now in our daily life we see a variety of motion. You see the fan is moving, the blood is flowing inside our arteries, you can say things, the bus is moving on, the rail is going on, and there are a variety of motion. Okay, now to begin with this topic, it is very important because in the 9th class physics, to begin with this physics, I want to say to you that to understand the physics you need to be a very good observer. Means you have to watch the things, you have to experience the things very keenly. Okay, you must be a very keen observer so that you can understand the daily life phenomena. Okay, what we are doing and what things are going to happen. Okay, now rest. So I can ask you that when can you say the object is rest, and when can you say the object is moving? Okay, because rest and motion are dependent on each other. Okay, now suppose a person sitting on a sofa, okay, or a person sitting on a sofa, or like standing on the road. Okay, and now there are two things. If he have a watch, he can see the watch and the time is continuously running. But with respect to time, with comparison to time, surely the person is not moving, means its position is not being changing. He is still standing on the road. Okay, suppose you are standing on the road and you see a watch, the time is continuously going and you are not changing your position. That means you are at rest. But at the same time, you are standing on the roadside and a bus is moving, bus is going. Okay, suppose here the bus is going in this direction. Okay, and looking to this, you see the bus is moving. Consider to whom? Whenever see that something is in motion, we compare the position of that object to us. Okay, whenever, listen my words, whenever we told that something is in motion, actually we are comparing the position of that object with us. Suppose a person is standing on the road and sees a bus is going, that he actually comparing the position of bus with respect to him, and he found that with respect to him the bus is changing position. If the bus is changing position with respect to him, then he says the bus is in motion. So motion, basically how to define a motion, is a very simple thing. Motion involves a change of position. Means certainly if you are in a motion, your position is going to change with time, because if you are sitting on a sofa, time is continuously running but your position is not changing. And if your position is changing, that you means you are running on a road, so your position is going to change with the time, then we say the motion is. Now as from this example, and I have said earlier that rest and motion are the two things which are heavily dependent on each other. Okay, now let's consider another example where we see the rest and motion are dependent on a person who observes the motion. Okay, rest and motion is a quite comparative. Okay, with respect to, means I see the motion. Okay, so whatever I am seeing, whatever I am experiencing, okay, that I have tell. Okay, so here I am saying that rest and motion, first point, that rest and motion are comparative. Okay, it depends on the position of the object, or you can say observer. Observer is a person who sees, who experiences the motion. Now I am saying that we are on earth. Okay, we are on earth, and we know that earth by itself revolving on its axis. Okay, ever we experience that there's a motion of earth? Have you experienced that there's a motion of earth, that earth is going round and round and round? No, of course no. Why? Because I have said, if you find yourself, or you can say, how can you observe motion? When you are standing on the road and others are in motion, you find yourself that with respect to your position, other is changing position. Then you consider the other person is motion. But I picture one situation where you are sitting in a train, and the passenger who is sitting in front of you, both of you consider that you are in rest. Why? Because although we know that train is in motion, but we don't consider that we are in motion. Why? Because with respect to you, the passenger's position is not changing. So whenever with respect to us, any other's object position is not changing, then we say that that object is at rest. Okay. And whenever with respect to us, other's object, other can be anything, other can be bus, other can be girl, other can be boy, other can be anything, other position is changing with time, we say that that object is in motion. So you came to know that motion heavily dependent of the observer, of the person who sees, who's experienced the motion. So I give one example. We don't consider the motion of earth. We never experience, because we are sitting on earth. Now the change of position, we are sitting on earth, and the change of position is same at every time for us. The earth is moving round and round, but we never see motion because we have not any reference to compare the position of earth. We have not any reference. So look, this ground on which a person is standing and bus is moving, okay, and we see that bus is in motion. This person tell you the bus is in motion with respect to ground, because ground is at rest, because ground is always at rest. So we want something, and here we take the ground as a reference. Okay, ground as a reference, and with compared to ground, we compare the position of others object. Okay. Now, so I have said that here I am only describing the comparative phenomena of motion. Okay, because motion is comparative. Rest and motion are comparative terms. Okay. Now you know the sunset, sunrise, the changing of cloud is due to the rotation of earth, and we never feel the earth is rotating, because the rate at which the earth is rotating, we are also at the same rate, we are also rotating at the same rate. So we never see the motion of the earth. Now, a passenger in the bus sitting, and these passengers looking each other and see they are at rest, although the person standing on the roadside see that bus is in motion, along with the bus, this passenger are also motion. So if you are going to ask this person what is the state of motion of these two passengers, then definitely he will say that they are in motion. And if you are going to ask from these two passengers, they say that this person is moving backward, or Often we traveling a train and we see that we are sitting and whole world is going backward. Okay, so most rest and motion are relative terms. So most motion in our daily life are very complex. Some are rotating, some are vibrating. So in our course we are going to learn a very simple case of motion, that is a straight line motion. A straight line motion is a motion in which we assume that object always travels in a straight line. Okay, that is the simplest case of motion. So we, in our motion, in our analysis, we will consider that object always travels in a straight line. Okay, so we are going to learn the simplest case of motion. Now to begin with, we need to define some terminologies, okay, to understand the motion. One terminology is the origin. What is origin? Now origin like on a number line, 0 serves as origin. On that side the numbers are going to be increased, on that side they are oppositely increased. Okay, so origin means, let's suppose I say that our school is 10 kilometers from my home. If I say that our school Sumati Academy is 10 kilometers from my home, so in this statement you see that I consider my home as a reference. I consider my home as a ground zero, is that point where the distance is 0, and with respect to my home I am measuring the distance. Suppose we say that Panna is 55 kilometers away from Chhatarpur, and in that case we take the reference as Chhatarpur. We say that the Delhi is 600 kilometers from Chhatarpur. Again the reference is being taken as a Chhatarpur. So reference or origin is that point where the distance are 0, and is also the that point where where the measurement are being taken. Suppose this is the scale. On the scales, a 0 is here and the marking is like that. So all the measurement are measured with respect to this 0. Okay, so this 0 is or reference. This is a reference point. Okay, so reference can be anything. Okay, so reference is at that point from where the measurement is being taken. Reference is at that point from where the measurement is being taken, or all the distance are going to be 0 at that particular point. Okay, so that is the term that is known as the origin. Okay, now as we are now, there are two things. Suppose there are two things, distance and displacement. Distance and displacement. Now what are they? Okay, suppose it is the origin. Okay, so here I am defining two more terms. Or starting position is also known as the initial position of the object. Okay, so this is the origin, and origin is always at a initial position is always at a origin. Okay, and where the motion object terminates its motion, where the object end its motion, that point is known as the final position. That point is known as the, suppose a ball rolls from point A to point B. Okay, and here it is stopped. Here it is stopped. So that stopping point, that ending point is also known as final position. Also known as final position. Okay. Now there are two things. There one is distance and there is displacement, and there is a wide difference between the distance and displacement. Okay, as we are discussing that case of straight line motion, distance is simply the total path. The total path covered by the object is simply the distance. Okay, the total path covered by the object is simply the distance. Suppose I am saying that from my home, the Sumati Academy is 10 kilometer. So that is the distance. That is the total path. And second thing, to define the displacement, we need to consider the position of the object. The starting position, or we can say initial position, or the final position, or we can say the ending position. And we define the displacement is the distance between initial and final position. Displacement is also a distance, but it is a distance between initial and final position. Whatever the distance between initial and final position is known as displacement. So here the difference. Distance is the total path covered by the object. It is independent of the initial and final position. And displacement is the distance between initial and final position. Okay. Now what happened? Suppose this is my home, okay, which I have taken as origin, and for origin I start my motion. So this is my initial position, okay, and this is the school. This is the school, okay. So what happened? I start my motion from my home to a school, and I return back from a school to a point. Suppose because we are considering a straight line motion. Suppose suppose from my home to school is a straight line. Okay, so I go from school to home to school, and return back from a school to and stop at a point C. So that is my final position. Okay. Now that C point is 2 kilometer away from final position, and as I have said, from home to school the distance is 10 kilometer. Okay. Now what is the distance and displacement? Now here you are going to understand the difference between it. As I have said, that distance is independent of the position. It is a total path. So from home to school, the distance is 10 kilometer, and from school to this point C, suppose it is a bus stand. Okay, suppose it is a bus stand where I have stopped. Okay, bus stand. So from a school to a stand, the distance is 2 kilometer. So overall I have covered 10 plus 2, that is 12 kilometer of distance. Okay, so that is the total path I have covered. But what about the displacement? Displacement, as I have said, that it is the distance between the initial and final position. It is the distance between this distance. It is the distance between initial and final position. So here we are concerning about this distance, because displacement is heavily dependent on the initial and final position of an object. So it is the distance between the initial and final position, and you can easily tell what is this distance. It is 10 minus 2, that is this distance is 8 kilometer. Okay. So at the same point, see, the distance is 12 kilometer and displacement is 8 kilometer. So what does it mean? It means that displacement is the shortest distance. Displacement is the shortest distance between initial and final position. Displacement is the shortest distance between the initial and final position, and distance is the total path covered by the object. Okay. So I hope you understand this concept of distance and displacement. Now we often link a direction. We often link a direction to a displacement, because if I want to know that what is the direction of the object, how can we know? For that case, we assume that if object moves in that direction is positive, this direction is negative, up direction is positive, this direction is negative. So that is positive and that is negative. And why we are going to introduce our positive, negative? Okay, so here positive and negative are the direction. Okay, here it is not like a math. it is here in the physics, the positive and negative in your course, the positive and negative is related to a direction. So we need to link a direction to a displacement. Okay, so whenever the object, so first kind of displacement is positive displacement. Positive displacement. Suppose this is the origin. Okay, so origin, initial position, and if the object continues in the straight path, okay, and stopped at this point, this is the final position. So the distance, the displacement you got, if the object travels in a straight path without returning back, whatever the displacement we get is always positive, because he continues his motion in a positive direction. Okay, so that positive means the direction. So that was the object original direction. He continues his motion in its previous or original direction. Okay, so here positive is associated to the direction. So we can say that object is moving toward right. Okay, now what happened if the object returning to point, reaching to point B and return backs? Okay, return backs. Now this is the initial direction, and after that object move in a straight line and reaching to point B, it returns back. So here whatever the displacement we get, we say that it is negative. Negative is simply the direction. Okay, answer we get it in a positive sense, but we write as a negative. Why? Because the negative shows us that the object has returned back. Object has returned back. So it is the meaning of positive and negative. We are linking the positive and negative to a particular direction. When the object is going straight, we call that the object is at positive displacement, and when the object is coming back, we call that object has a negative displacement. So here positive and negative are linking the direction. Now the third case, zero displacement. That is the third case. Zero displacement. Zero. Displacement is zero. Now, suppose I goes from my home to school and again return back from school to home. And suppose the distance from my school to home to school is 10 km. So in going, I have covered a path of 10 km and returning back to the same initial position, as that means home. Again I have covered the path 10 km, 20 km distance I have covered. But what could I have say that my displacement is zero? It is very strange, but it is true. Suppose here I have this is my home, and suppose this is the school. Okay, and distance here is 10 km. So in going, I have covered a 10 km distance, and in coming back I have covered a 10 km distance. But I have started my motion from that point, and this point is the origin. This point is the origin, and I have also stopped my motion at this point. So this point is also a final position, because I return back to my home. So there is no distance between initial and final position. I am standing on the ground zero, because here there is no distance between the initial and final position. So if the object returns back to its origin, to its initial position, we say the displacement is zero. Okay, so this is the type of displacement. I hope you understand. Okay, thank you.